So let's start to begin with the ionic bonding. Okay, so Aksa, right? Amna. Okay, Amna, let first of all tell me that what type of elements are going to do ionic bonding? What type of elements?
Ions.
There, like ions are involved, but what type of elements? Like if we go with the periodic table, goes with the periodic table, what type of bond elements are going to do the ionic bonding?
Metals and non-metals react.
Metals and non-metals, yes, they are going to do the ionic bonding. And first of all, why is the like, there is something that we want to like the elements are going to have why they are reacting. First of all, let me first of all start with it. Why elements want to react? Like we know that metals and non-metals are going to what happened. Okay, so what type of elements are there? We are having metals and as well as we have non-metals. So basically metals react in a way in order to lose their outermost electrons, because metals are having one, two, or three electrons in the outermost shell. If you go with the periodic table, we know this thing that we are having um, eight groups in the periodic table, and the eight groups are having like in the first three groups we are having the metallic groups, that is group number one, group number two, and group number three. So basically we are having metallic group number one, group number two, and group number three. They are the metallic groups. Then group number 4 till 8. Group number 4 till 8, we are having non-metallic groups. Okay. So basically, if we if we go in the structure, for example, this is the structure of sodium, and atomic number of sodium is 11. Fine. So if we draw the outermost structure, like the structure, electronic structure of sodium, then in the first shell we are having how many electrons? There is a division of shells under the electron. The first shell will have 2 electrons out of 11, because the maximum capacity of the first shell around the nucleus is 2. I hope you know this rule of filling.
Yes.
Okay, so the second shell will have a capacity of how many electrons?
It will have a capacity of 8.
It will have 8. So 2, 8, and the last shell will have the capacity of filling 8 or 18 electrons. That's the number, that's the capacity. Minimum 8 electrons should be filled in the third shell, that is KL and M shell. M shell will have minimum of 8 electrons and maximum 18 electrons should be there if we are going to fill up the shells. But usually the metallic in the metallic case, in the case for IGCSE and O levels, we are having the simple metals associated with our with the bonding. So in the third shell, sodium will only have 1 electron by default, because the atomic number of sodium is 11. So the electronic configuration of sodium becomes 2, 8, and 1. Fine. I hope it is clear. Till here?
Yes.
It is 2, 8, and 1. Okay. So in the second, sodium is left with only 1 electron in the outermost shell, and that's why this 1 electron makes this sodium quite unstable. This 1 electron is creating uneasiness for the sodium, because according to the rules of stability, there are two rules. The first rule says that any element can become stabilized by having 2 electrons in the outermost shell. This is the rule that is called duplet rule. This is the first rule for stability. It says that any element in the first period, and in the second period we are having only 4 elements under this rule. That is hydrogen. Then we are having helium. Then we are having beryllium, Be, and then we having the fourth element is beryllium, and then we are having boron. So hydrogen, helium, lithium for the third, first group, and beryllium and boron. There are total 5 elements associated in this principle that says that these 5 elements, I repeat, hydrogen, helium, lithium, and beryllium, as well as boron, will become stabilized if they have a number of 2 electrons in the outermost shell. So these 5 elements are going to attain stability by losing their respective number of electrons to get a number of 2. Okay, that's the first rule, that is called the duplet rule. I hope that you must have done this rule. Okay, are you familiar with this rule? This is the first rule for stability of initial 5 members of the periodic table. The second rule suggests that is called the octet rule, OCTET. That's the octet. Octet rule is valid for respect like all of the rest elements of the periodic table. It says that any element other than these 5 elements will become stabilized if it will have a number of 8 electrons in the outermost shell. So if we look at the sodium is apart from this initial list that I have shared for the duplet rule. Sodium is going to follow the octet rule. So that's why if you closely look at the sodium, it will tell us that first shell will have 2 electrons, the other shell will have 8 electrons. So rule of stability implies over here. At the second shell, that is basically called the L shell, is stabilized by having 8 electrons. But the third shell, that is the M shell, is unstable because of only the 1 electron is present inside this shell. So what sodium and other metals will do, they are going to leave or lose this extra electron to the non-metal atom nearby. So for example, we are having a chlorine atom in the surrounding, and chlorine atom is a non-metal atom, and it must have greater than 4 electrons in the outermost shell. That's again another rule or a statement that metals atoms will have 1, 2, or 3 electrons respectively in the outermost shell when morning, and the non-metals will have greater than 4, 5, 6, 7, and 8 electrons in the outermost shell. So up till here it is clear?
Yes.
Okay. So okay, let me clear. So over here, if you can see that sodium is having 2, 8, and 1. It is only 1 electron in the outermost shell, that's over here. And it's going to lose their electron to the chlorine because chlorine atomic number is 17. And if you divide it accordingly to the shell configuration, it is 2, 8, and 7. And plus never comes. This is wrong. Plus never comes. Never write in electronic configuration. It is always separated by commas. 2, 8, 1, and for chlorine it is 2, 8, 7. So, Acha.
Okay.
Yes. Any problem?
No.
Okay. So chlorine, and there are few rules and few steps to draw electronic configuration and the ionic structures. First of all, the metal. We have shown the metal. Let me zoom it first. We have shown the metal atom with okay, this is fine. Okay, we have shown the metal atom using the dots. We have shown the metal atom using the dots, fine. And the other non-metal atom and the last shell is the last electron is drawn over here. And we have shown the other elements electron, that is a non-metal, using the crosses. 1 dot and 1 cross should be like combined, but the non-metal to have a structure. So over here, okay, so over here we are having 281 configuration and the other configuration is 287. So chlorine can become stabilized if it has one more electron, because you can see it is 7. And what was the octet rule? What was the octet rule saying? Yes, what was the octet rule? Octet rule suggests that any element can become stabilized if it has total number of 8 electrons in the outermost shell. So chlorine is having only 7. So how many it requires in the last?
It requires 1.
It requires 1. And sodium has to leave 1. So it will lose this electron to this unbonded chlorine atom. Fine. And over here, they are going to become paired up by losing and gaining of electrons. So there are again some rules. Initially, when we are going to make the ionic structures, we are not going to have any square brackets on the reactant side. There should be no square brackets. There's only a plus sign. A plus sign in between sodium and chlorine atoms. there's no square bracket, the electrons are you would say they're unshared, they're unpaired. One of the electronic electrons will be unpaired. Like in sodium, this is the unpaired electron, and in chlorine, this is the unpaired electron. So on the next side, like after the reaction, after the arrow, we have to draw two square brackets that are already drawn, and the brackets are always squared. They're not circular, or the brackets that we use in maths. So they are square brackets. Then we have to draw first shell, then the second shell, and third shell electron is already lost. So we need not to draw the third shell. So sodium becomes stabilized by having 2 and the 8 electrons in the outermost shell separated by a square bracket. And how many electrons sodium has to will lose? For example, it has lost only dash electrons. Yes, Amna, how many electrons sodium has lost?
It has lost one.
Only one electron. So we have to add how the number of electrons that are lost creates a positive charge. So it will have a +1 charge, and or 1 is normally not written, so we can also write plus. Plus means +1. And the chlorine was having 3 shells, 2, then 8, and then 7. And in the 7th, like if I'm talking about the 7th electron, then the 7th electron will be drawn like this. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 2 and 8 are done. Then the third shell. Third shell will have like this. We can draw the third shell, and we have to fill the electrons.
It will have 8.
1, 2, 3, 4, 5, 6, and 7 and 8 will be the cross. Like this.
Okay.
We have to separate we have to separate the drawing of the cross, because we have to separately show the electron. Over here, I have just done a mistake, because crosses were shown for chlorine and dot was shown for representing basically sodium atom. So we have to make all the dots as crosses, and the transferred electron will be shown as a dot. So this is some of the mistake. Like these are the crosses: cross, 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 cross for chlorine, cross for chlorine, another cross in the last shell for chlorine, and thus the sodium electron will be shown by a dot. This is basically called, this new pair that has been formed is basically called bond pair. The electron pair that is formed by the bonding of non-metal versus a metal electron is called a bond pair. I hope it is clear. The new pair that is just formed is called a bond pair, whereas the electrons that are already paired up, do you know their names? The electrons that are already paired up are having another name. We call these electrons as lone pair, L-O-N-E, and then P-A-I-R, pair, lone pair of electrons. So the electrons that are already present bonded, like they have paired up, like the electrons that are already left in pairs on the same element are called lone pairs, and the electrons that are just bonded together from a metal and a non-metal, the combination of a non-metal and metal electron are called as the bond pair. I hope it is clear.
Yeah.
Okay, done. So this was a bonding between sodium and chlorine to form sodium chloride. So this is how you have to draw the structure. And in IGCSE, what comes in exam? In exam, they ask you to draw the electronic structure of sodium ion, or they ask you to draw the electronic structure of chlorine ion. First of all, so you have to draw these structures, the final ones. You have to draw the final ones. In IGCSE and CIE, they don't ask you to draw the initial structures most of the time. Most of the time, they only ask you to draw the electronic structure of a sodium ion or a chloride ion, for example. Otherwise, in the other cases, they ask you to draw the structures, draw the electronic structure of a sodium atom or a chlorine atom. When they say the atom means atom is having a full electronic configuration. And when they say a non-metallic, like when they say ion, then they means that you have to draw an ion which has already lost or already gained an electron or respective number of electrons. I hope that's clear.
Yes.
And all of these structures are usually of 1 or 2 marks, not more than that. There are one of 1 mark. Usually they are of 1 mark, and very rarely the structure can come for 2 marks. If they come for 2 marks, then you have to write down the electronic configuration and you have to write down the you have to draw the structure as well. And if it comes for only 1 mark, then you must directly draw this structure like this. Okay.
Okay.
Sometimes they also give you a question and they ask you, in terms of loss and gain of electrons, explain. In terms of loss and gain of electrons, explain or describe how sodium and chlorine makes sodium chloride. So in that case, Amna, what you have to do, or what student is supposed to do, I repeat a question. In terms of loss and gain of electrons, describe how the sodium forms an ionic compound with chlorine to form sodium chloride. So in that case, what we have to do, in that case, okay, in that case, you have to describe the bonding from here. I'm reading the part of the book for your understanding. Okay, as you saw on page 49, a sodium atom must lose 1 electron and a chlorine atom must gain 1 to obtain stable outer shells of 8 electrons. So when a sodium atom and chlorine atom react together, the sodium atom loses its electron to chlorine atom and 2 ions are formed. 2 ions means 1 sodium ion and 1 chlorine ion. Here sodium electrons are shown as dots and chlorine atoms are shown at first. So you just have to describe that how many electrons are deficient or efficient or excess in chlorine. So the 2 ions have opposite charges, so they attract each other. The force of attraction between them is so strong, it is called ionic bond. So I hope that you have got my point, that how you're going to describe the bonding between sodium and sodium chloride. Okay. So is there any question?
No.
Okay. So another type of bonding is again frequently asked question in the IGCSE NCA exams is the bonding between magnesium oxide. Very like we would say this question is also frequently asked. This is a very common ionic compound, that is magnesium oxide. The special thing is in this compound is that this compound is having a metal again, that is magnesium, and a non-metal, that is oxygen. Now over here, magnesium belongs to group number 2 of the periodic table and oxygen belongs to group number 6 of the periodic table. Do you know what is the relationship between group number and the elements?
The group number is the amount of valence electrons.
Amount of valence, exactly. The group number tells us the number of valence electrons, not the amount. And so that's why the magnesium will have, and if we go to the atomic number as well, the proton number, it says that first shell of magnesium contains 2 electrons, then the other will have 8 electrons, and the other will have again 2 electrons. Whereas first shell of oxygen will have atomic number 8. First shell having 2 electrons, the other shell will have 6 electrons respectively. So can you see the relationship? How many extra electrons are with magnesium?
2.
2. And how many electrons are required by oxygen?
2.
2. So what they will do? 2 electrons will be supplied or will be transferred or will be lost by the magnesium atom, like 2, 8 and 2 are there over here. And one thing more. Students usually do a mistake, and before that I was also checking the papers of my students. Students usually do a mistake that when they draw the magnesium structure and when they draw the neutral structure of magnesium atom, they join these dots. They make paired. They make the 2 leftover electrons, these 2 electrons with the extra electrons in pairs. That's totally wrong. In the book, how it is represented, you have to draw it like that. You have to make two separate dots opposite to each other, so that you must know that 2 electrons are going to be transferred to 2 different sides. You don't have to transfer the whole pair as well. If you transfer the whole pair, your marks will be deducted. So you have to show the individual extra electrons separately. Then in chlorine, if I draw the structure of chlorine 2, then oxygen 2 and then 6. So first shell will have 2 electrons. The next shell will have 1, 2, 3, 4, 5, and 6. You know how I have made the electrons? That's again a very good way to write down, to draw the structure. I have shown it like that. I again repeat it so that you may learn. First shell and the second shell. Fine. And how you're going to draw the electrons? Diagonally. 1, 2. Okay, this is it. 3, 4, 5, 6, 7, and 8. So by drawing diagonally, by drawing like a plus, imagine there's a plus sign in between. When you draw it like this, then you will see a clear indication of how many electrons are being left. So again, 1, 2, 3, 4, 5, 6. So 2 pairs are there in the final shell, and 1 unpaired electron is left. And from magnesium, we are having 2 unpaired electrons as well. So magnesium is going to transfer this electron to this unpaired electron and this electron to the next unpaired electron. So this is how you can represent the bonding and transfer of electrons between magnesium and oxygen. I hope it is clear.
Yes.
Okay. Now, so after the reaction, and then you don't have to rub it. Before the reaction, just draw the arrows. Just draw the arrows to show, but do not transfer. Transfer it afterwards. After drawing the arrow, that is after the reaction, then make 2 separate square brackets. Draw the magnesium atom without these 2 electrons. So don't draw the last shell, and write down the respective number of charge, that is +2, because 2 electrons have been lost on the top right corner, and that's the only place where you can place the charge, nowhere else. Okay, and on the top right corner, you have to show the gained electrons, that is oxygen has gained 2 electrons, so 2 negative charges will be over here. So -2 and +2. And this is the magnesium bonding between magnesium oxide. And on the lower part, you have to write Mg +2. And then you have to write down the final leftover configuration, that is 2 and 8, because 2 electrons are gone. And below oxygen, just below oxygen, you have to write O -2 in a square bracket. Then you have to write the full configuration, that is after the reaction. 2 and the last shell will contain how much?
The last shell, it will contain
8 or 6?
8.
8, yes. So you have to write down 8 like that. This is how you have drawn the structure for whole, if the whole structure comes, then it will be 4 marks. If only they ask you to draw the final structures, electronic structures, then this will be for 2 marks. Or sometimes IGCSE examiners give you more marks, but in CAIE, there's a tough marking criteria. So it's good that you are in IGCSE, so you will gain good marks in exam. So ions attract each other because of their opposite charges, and the resulting compound is magnesium oxide, and the formula is MgO. It has no overall charge. Okay, so a question come in exam related to this magnesium oxide or magnesium chloride, magnesium oxide, that a question come in the exam that why magnesium oxide is having a very high melting point, that is 2840 degrees centigrade, as compared to the bonding in NaCl, and it only have 808 degrees centigrade. The bonding in NaCl, it's also an ionic compound of a reactive metal. The bonding is ionic as well, but it has 808 degrees centigrade melting point, sodium chloride. But magnesium oxide is having a more than, like, it is 3 times higher as compared to NaCl. Why? Can you give me the answer? Why?
Could you repeat the question?
Why magnesium oxide is having a very high melting point as compared to sodium chloride? Both of the substances are ionic compounds in nature. We have done with sodium chloride, and we also have done it with magnesium oxide. How many electrons were transferred by sodium to chlorine in sodium chloride?
1
Only
electron.
1. And over here, how many electrons are being transferred by magnesium?
2.
2. So that is why each and every time, because it makes a giant crystal lattice, It is not a single molecule. Ionic compounds are not molecular in nature. They are having a giant crystal lattice. They are having a cage-like structure. So because of the cage-like structure, each magnesium is going to attract, each magnesium ion is going, this is how the structures are going to be made. This is how you can relate it to that. Each magnesium positive 2 is being attracted by each negative 2 oxygen, then positive 2, then negative. Like means 2 electronic force, the twice electronic force is applied everywhere in magnesium oxide molecule, whereas one time force is applied for sodium chloride because only one electron has been transferred. So the force multiplies by twice, and because it implies at all the four corners. That's why magnesium oxide is having a high melting and boiling point, because 2 electrons are being transferred. So double force is applied between the opposite charge ions and from the other sides as well. That's why magnesium oxide is having a, you could say 3x times high melting point, boiling point as compared to the sodium chloride. I hope it is clear.
Yes.
Yes, so any question, Amna?
No.
Okay, so this is all from my side. Inshallah, see you next time. Okay, take care. Allah Hafiz.
Allah Hafiz.